Hi, linear algebra students. Section 1.2, the second overdetermined system. Okay. Okay, so the reason I did this on the board is to make you see that the second overdetermined system is the same as the first overdetermined system, but instead of having a 0 here, it has a 1. Okay? So what I'm going to do is I'm going to correct the calculations that we have in order to take into account of that change. Okay, so I will just write here instead of 0. Okay, so obviously we have a 1 over here instead of, well, the 0 that we would normally have. Notice that it doesn't change how we create the pivots. So the row operations, well, I'm going to tell you something in general. The constants do not affect which row operation need to be performed, not the column of constant that's over here. So you'll see that we will perform the exact same row operation. What's going to be different is the result. So for example, here, we are looking at this row operation. Okay, row 4 minus row 1 becomes row 4. So it becomes now 1 minus 1, 0. Okay. Then, the same thing that we did in the overdetermined system number 1. Notice that these rows are opposites of each other except for the constants. And now we will use this to our advantage to actually shorten the process, like shortcut actually. So we're doing the same row operation. Row 4 plus row 3 becomes row 4. Now what's going to happen is 0 plus 1 is going to make this become 1. Okay. As I can see though, it is not exactly the row echelon form that we have in our notes. But okay, let's actually erase everything over here. Remember that here with this row, well, it's not a row echelon form, but with this matrix, you can already conclude that your system has no solution because the last row means 0 equals 1. So in other words, your equations contradict each other because 0 equals 1 is false. However, if you wanted to really bring this into row echelon form, what you would do is you would, that's it. So you would perform this row operation and you would get this. And to get the matrix that is in your lecture notes, notice that this is really not necessary. The last row operation you need to perform is row 3 times negative 1 becomes the new row 3. And then what you have is exactly the matrix. I should correct this. This is 1 now. And now the matrix that you get from here is exactly the one that is in the note. So 1, 1, 1, 1, 0, 1, negative 1, 2. And the only row that's changing is the third row. And we have 0, 0, 1, 3. And finally, 0, 0, 0, 1. Okay. Now, what I want you to see is that all of this until the very end here, this part is not necessary. Since we already know that the system is inconsistent. And this is it. So this is the second overdetermined system that I just gave this matrix to. See you for the third overdetermined system.